All right, hi kids. So today we're going to work on lesson 512, investigating scale factors and working with them. So it's just an extension of what we did yesterday with determining if two shapes are in fact a dilation and going through those properties. So now today what we're going to do is we're going to investigate scale factors, basically knowing that the dilation has occurred and just determining what that scale factor is. So it's really just a little step further from what we did yesterday. So in your textbook on page 25, we're going to start with the warm-up. All right, so what I want you to do is I want you to go through these problems after I read it, pause, go through it, and then play the recording and see if you got the right answers as I kind of explain some of it. So Hideki is babysitting his little sister and takes her to the park. While pushing her on the swing, he notices that if he pushes her so that she swings as high as the top of his head, and then she lets go without pushing her, she only swings as high as his shoulders. So what it's trying to show is that the swing is slowly reducing the height. So it says if Hideki is 6 feet tall and the height of his shoulders is 5 feet 1, what is the scale factor of the change of height of his sister's swing? So I want you to do 1, 2, 3, and 4. Don't worry about 5. 5 is unnecessary, but just I want you to practice 1, 2, 3, 4. So pause the video, try 1, 2, 3, 4, and then we'll go. All right, so here we go. So here are your answers. So again, if Hideki is 6 feet tall and the height of his shoulders is 5 feet 1, what's the scale factor of the change of height of his sister's swing? So again, he starts here. This is the old, and then she ends up at the height of his at the height of his shoulders, which is the new. So for scale factor, I don't know why it's erasing, is new over old. All right, so we learned that yesterday. Your K value, K, is new over old. That's how you find your scale factor. So the new height was 5 foot 1, but the original height was at the head, which is 6. So 5.1 divided by 6 is 0.85. All right, so now, ready? It says write this change as a percent. So again, we had worked on this in the statistics unit. All right, boom, 1, 2. You move the decimal over, 2 times to the right, and you get 8.85%. Now it says, go back to the original fraction, right, and write through what is the reciprocal. Reciprocal means flip. So you're going to flip your fraction, and you get 6.5 or 6 over 5.1. And then what is the reciprocal change in the height? So I just simplified it to 1.18. And then how do you write 1.18 as a percent? Well, it's 118%. So we don't want to worry about 5, but this is really just connecting what we did yesterday and applying it today. So today we are going to know what a dilation is, which we went over yesterday, but we're going to continue working with the dilation and determine if that dilation is an enlargement or a reduction. How we determine that is your K value, which is your scale factor. All right, your scale factor, or K, will tell you if it's an enlargement or a reduction. All right, because yesterday on our notes we learned that if you have a K value greater than 1, it's an enlargement. Which means it's big, it's gotten bigger. If you get a K value that's less than 1 but greater than 0, so really like a decimal, all right, that's a reduction. All right, and then if you have a K value equal to 1, it's congruent, because your K value is what really you're multiplying to get to your new figure. So now the second thing what we'll apply today is, can I use a scale factor to find measurements of a dilation? So now we're going to apply the scale factor to find new measurements. So with that said, on page 27 we're going to start with our first example. All right, so remember, going through this, you can pause, rewind, and listen to it again if you didn't hear something or it didn't make sense. So example 1 says, if segment AB has a length of 3 units and is dilated by a scale factor of 2.25, what is the length of A prime, B prime? Does this represent an enlargement or a reduction? Well, technically, we could actually determine this second part right away, because enlargement and reduction is based on what is your scale factor. So just like what I did on the notes before, if K is greater than 1, it's enlargement. Enlargement. engagement, which means ENT, which means your shape is getting bigger. So in this case, your segment is growing by 2.25. Doesn't mean you're adding. We're going to show what that happens. But this is actually an enlargement. So if you go down here, even though 1 is determine your new length, here 2 determine if it's a dilation. Well, K is greater than 1, which means enlargement. I apologize. My computer is really funky. It stinks. I'm not writing in orange, just letting you know. So anyway, back up here. So we know it's an enlargement. Great. So our shape should be getting bigger. So now what we're going to do is we're going to figure out our new length. This is your new. Prime means new. A prime, B prime means new. So to find your new length, you multiply your scale factor to find your new segment. So what we're going to do is you go AB. If you multiply it by your scale factor of 2.25, you're going to get A prime, B prime. That's what you're going to get. So AB's length is 3. So we're going to go 3 times 2.25, all right, equals, oops, I don't know why it's drawing, oh, and of course it's doing this, which is lovely, whatever. All right, so you're going to go 3 times 2.25. So in your calculator, you'll get 6.75. So that's the measurement of AB. And now here's the thing, ready? Units, because it's 3 units long, UNITS. Boom. That's how long A prime, B prime is. So if you wanted to really officially write it out, A prime, B prime equals 3 units. All right, cool. And then we said on part 2, K was greater than 1, so it's an enlargement. Awesome. So here we go. Now, number 2. So number 2 says a triangle has vertices G, H, J, and then it says if the triangle is dilated by a scale factor of 0.5 through the center 0, 0, 0, what are the image vertices? So it's asking what are the new coordinates? Sorry, coordinates. I apologize. My computer is being unbelievably awesome right now, so bear with me. So that's what this is. What are your new coordinates? So it then says draw the pre-image and image on a coordinate plane. Well, we'll kind of draw a sketch, a mock sketch, but here we go. So kind of like what we did yesterday to determine if a dilation happens, we can actually use coordinates to find our new coordinates and our scale factor. So what I'm going to do is I'll take G, which is 2, -3, all right? And what I can do to get to G prime, all right, all I'm going to do is take this scale factor of 0.5 and I'm going to multiply everything by 0.5. Multiply this by 0.5. So everything you're going to multiply, all right, multiply both X and Y by the scale factor. That's how you find your new shape. So what you'll do, ready? 2 times 0.5 or 2 times a half is 1. -3 times 0.5 is -1.5. So that's how you get G prime. So now you're going to continue. You're going to do that with H. So H is -6, 2. So you're going to get H prime. Again, multiply everything by a half, so times 0.5 times 0.5. All right, so -6 times a half, or 0.5, is -3. 2 times a half is 1. And then lastly, your last one is J. J is 0, 4. I love 0 because anything, whatever your H value, sorry, this should be a J. Whatever your J prime, whatever your scale factor is, anything times 0, so times 0.5 times 0.5. All right, so 0 times 0.5 is still 0, but 4 times 0.5 is 2. So these are your new coordinates. So this is your new coordinate. So now, ready? So let's see. All right, we're going to graph just what this sucker looks like. Now, this is a little mock graph. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so here we go. Ready? I'm first going to draw GHJ. So G is 2, negative 3. Here's G. H is negative 6, 4, 6, positive 2. There's H. And then J is 0, 4. So up 4. Here's J. So boom, boom, boom. Now, ready? In green, I'm going to draw these. So since our scale factor was 0.5, we need to say, hey, since our scale factor is 0.5, this thing should be a reduction. We should be thinking this, or if it asks a question, we'd be like, hey, it's a reduction because it's less than 1. But when we draw it now, we should know or be aware that this should be smaller. This new graph should be smaller. So here we go. Ready? 1, comma, negative 1/2. So right 1, down 1.5. So that's about here. Here's G prime. H is negative 3, 1, 2, 3, up 1. Here's H prime. And then J, 0, 2, boom, there's J prime. Boom, boom, boom. Now, if you look at that, that triangle looks significantly smaller, and it should be. It's half, because our scale factor is 0.5, it's half the size of your original one. So now we're connecting coordinates with our scale factor, and our image should match, even though we graphed it not even on real graph paper, but that looks definitely smaller. All right, lastly, here we go, number 3. Number 3 now says, what are the side lengths of triangle D prime, E prime, F prime? So what are your new side lengths? With a scale factor of 2.5, given, it's not conditional probability, this is just saying given, knowing the pre-image and image below. All right, so here's your image, so clearly you can see your regular shape is kind of small and your new image, your prime, is big. And we should know that. Oh my gosh, look at that, your scale factor is 2.5. All right, so when you look at this with a scale factor of 2.5 here, all right, you want to say to yourself, I know that this, where's my pen color? Come on, buddy. This right here is in large, E-N-L, okay, E-N-L-A-R-G-E-M-E-N-T. Okay, sorry. All right, it's an enlargement. So naturally, the picture, it should be bigger. Clearly, the book already gave it to you. So it should be 2.5 times bigger since that's your scale factor. But anyway, here we go. So how do we figure out our new side lengths? So check this out. What you do, just like the coordinates, is you're going to take your side lengths and you're going to multiply them by your scale factor. So we're going to go and get D prime, E prime. Oh man, almost done, buddy. Come on, help me out here. I don't know why this is happening, kids. I apologize. Some of you are like, I'm already done, dude. Okay, so what you do is you multiply by 2.5, all of these. So D prime, E prime is going to be 1 times 2.5. Come on. Oh boy, wow. So this should be 2.5, all right? So this D prime, E prime, oh my goodness. Oh boy, of course you would do that. So D prime, E prime has got to be 2.5. You're all sitting there probably laughing. It is funny. Disappear, of course, 2.5. All right, so here's the deal. You just multiply all these by 2.5. 2.5, and you can't even see my work. 2.5. Oh my goodness. Wow. This is awesome. So here's the deal. I can't finish because apparently this is not working. Let me see one more time. I'm not a quitter. This is BS. Come on, man. Times 2.5 times 2.5. So I'm gonna do this. I'll sit here for 30 minutes and we'll get this sucker. So clearly DE is 2.5. D prime, E prime. So now, all right, E prime, F prime, this, once you multiply by 2.5, 9.2 times 2.5, you should get E prime, F prime should be 23. So that should be 23. E prime, F prime. All right. Oh, of course that erased. Of course you erased. That's great. And you can always pause the video, go back and look at it. And then here we go, last one, F prime, D prime. All right, so you take FD, multiply by 2.6. So 8.6 times 2.5, and you're going to get 21.5. That's what you get when you multiply by 2.5. Boom. All right. and that's what your side lengths are. So here's the deal. Rewind, look at it, laugh, have a good time, but this should have been a review, all right? Please be sure to do your homework tonight, which is page 31, 1 through 10, all right? The answers, again, are in the back of the book, but for this homework, 1 through 10, if you were to go onto Google Drive, you'd be able to see all the answers right here, okay? So make sure that you're working on this. If you have any questions, all right, I'll be back and you can ask them then, all right? Have a good day.